Hey, hello, good morning, everyone. Good morning, Wyoming. Very excited to be here in that event and participate here, and to get the opportunity to speak to you about financial contracts on Cardano, and in particular about Actus contracts, which you could say is a special class of financial contracts on Cardano. I'm here with Dmytro, who will actually take the second part of that session. I'm going to speak first about Actus itself, give you an intro and some background about Actus is and what our goals are with Actus. And then Dmytro will continue and show you some examples of actual Actus contracts implemented in Marlowe, so they can be executed on Cardano. So let's jump right in. Financial contracts. What are financial contracts? And the essence of financial contracts we can describe with agreements between two or more parties on the exchange of future cash flows. So we do look at a specific class of legal contracts, of agreements that govern how two or more parties interact with each other. And by interacting, we mean under what conditions they exchange what cash flows at what points in time in the future. So that type of contracts does not cover other contracts, other agreements like an employment contract, where parties agree on what the work is that an employer has to do, what the performance is according to which he is measured, and what the salaries and stuff like that. Or other contracts like a lease contract and stuff. Specifically covers contracts that we know from the financial sector around exchange of pure cash flow back and forth. As an example, I show here a straight bond, a very simple instrument on capital markets. You see here on the very left a term sheet, a simplified term sheet for that straight bond. You see in the middle a contract schedule that is projected using those terms. And then here an explanation on now what do those arrows mean. You see here there are arrows going from top to bottom. So that means the investor sitting on the bottom making a payment to the issuer and vice versa. What that contract really does here is it's a lending agreement that can be secured by assets, by guarantee and whatsoever, such that an issuer raises funds, makes interest payment over time, and repays those funds at the end. That's a very simple financial contract. More complex financial contract could be an annuity that has a rate of interest that is periodically reset. I just realized that the title here is actually misleading. It's not a fixed rate, it's a variable rate annuity, and it has a grace period, which means actually the lender, the issuer, doesn't have to repay right away, but he's given a grace period within which he doesn't have to repay outstanding amounts. So that's a more complex financial contract. And when we look at the financial industry, and those bubbles here should indicate different areas, different sectors within the financial industry, and the volumes that are issued within those sectors of financial products. What we see when we look at that is actually, so finance is essentially nothing else than dealing with financial contracts, right? So different types of financial contracts, let's start with stocks here, bonds, as we've seen before, other credit, private or public credit, derivatives, and so on. But those are all financial contracts in the end that are dealt with by the parties involved. So financial contracts obviously are a very important class of contracts, in particular in the financial sector. Now, what do we do at Actus? What is our mission? We want to break down that diversity of financial products, financial contracts, into a manageable number of cash flow patterns. We call these cash flow patterns algorithmic contract types. And that is because these cash flow patterns, these contract types, the goal is that they can be recorded and executed electronically. And if you have been exposed to the financial sector, you know what different products exist, from very basic straight patterns to exotic patterns, and that it's quite a challenge for institutions dealing with all those different types of financial products. And imagining that we would be able to deal with that variety with a handful or a couple of handful basic patterns, that would tremendously simplify many aspects of finance. So that's our mission at Actus. I actually didn't introduce really what Actus means. I just do that now quickly, and you can see it in our logo up here. So Actus stands for Algorithmic Contract Types Unified Standards. And that points to the fact that those contracts are algorithmic in nature. They are unified, or the model of those contracts is unified across different sectors within the financial industry, and that those patterns are standardized. How do we do that? How do we standardize or streamline all those different types, all those different products within one standard? And we start by observing that financial contracts are essentially state machines. You can look at financial contracts as state machines. Now, we have that generic pattern according to which we actually want to represent all kinds of products, just as state machines, right? And just as how state machines work, we observe a number of key elements that are important for such a model. We start by terms. So terms in our model represent the contractual terms that are agreed upon by the parties that engage in a contract. So the initial terms that they set when they execute the contract. We observe that there are events that happen during the life of that contract. There is state of the contract. So we observe certain variables, certain dimensions of that contract over time. And we have state transition, which means the state of a contract changes from one instance in time to another. And we have payoff, which essentially means that there is a payment obligation that is triggered by a certain state change. And that's that very basic model according to which we unify and represent financial contracts. And you can observe, obviously, that model works as follows. We initiate the state of the contract with the terms at time 0. There are certain events that are derived from those terms. Those events, they can actually be scheduled, which means we have seen in the first example that periodically interest payments have to happen. It's agreed upon by the parties at initiation of the contract. And those payments, they happen or have to happen at certain points in time. We also observe that there are events that are actually not scheduled. If we look at, again, the bond example, the issuer might have the right under the terms that he can redeem early. So that's one example of an event that's acknowledged under the contract terms, but it's not scheduled. It can happen at any time. So those events, scheduled or not scheduled, are applied to the state at the time they occur, applied to the state, and two things happen when we apply those events. One thing is a state transition function is applied that triggers a new state. And the other thing is a payoff function is applied that triggers a payoff. And that payoff can be 0 or can be greater than 0. 0 indicating that no obligation happens at that instance of time. So that's the very basic model that allows us to abstract that variety financial products into a manageable number of entities within that model and represent different types of products. Then some other principles that we follow when we develop that model or that standard is we always want to represent or capture the dynamic aspect of financial contracts. So we actually capture data and algorithms. There exist standards in the financial sector like FIX or so that have another scope that, for instance, are used as trade protocols where parties exchange data on trades that have to be settled or are settled and so on, which essentially are static, if you will, data elements. With Actus, we want to capture both data and the algorithms, which mean how does the contract evolve along time. Breadth and depth, meaning we do want to cover the entire financial industry and not a specific sector. There are other standards that focus on one specific sector, like derivatives, as ISTA does. We do cover contracts cross-sector. And depth, when we develop a contract or capture the features of a contract, we capture all those little details that define that contract, including stuff like day count conventions and so on. So very detailed representation of contracts. A key concept that we also use is composability of contracts. So having one basic contract, one pattern, you can combine that with other patterns to create actually more complex patterns. And that allows us again to break down the entirety of patterns into a small number of basic patterns. And by combining those patterns, you would arrive at more complex, more exotic contracts. And then finally, full life cycle coverage. All aspects of a life cycle of that contract should be considered, indicating different types of corporate actions like the events that we have defined, and not just, let's say, pricing of a product or not just the trading in the sense exchanging contracts or fractions of a contract. Those are the basic principles, and following these, the Actus standards consist of two things actually. One is that data standard, which essentially is a dictionary of contractual terms that are covered, that are used by those different products. And the other standard is an algorithmic standard, which essentially is a description of the logic, of the business logic of those different basic contract types, according to which they evolve over time. So taking again the notations introduced above, describing these schedules of financial contracts, which events are triggered at what points in time according to the terms. What happens when an event is applied to a state? So what are those state transition functions and what are those payoff functions? So these are described in a mathematical form in that part of the standard. Then on top of that, Actus also has a reference implementation in Java that can be freely downloaded, just like any other elements here. What I show here is the taxonomy of Actus, where you can actually see that there's really have a very broad scope of what products, what financial contracts we cover. And just to name a few, you find on the left side here some basic patterns. Under those basic patterns, there are maturities. You can also see those as fixed income contracts. You find bonds, just loans, different amortization patterns, but also then bank accounts which are non-maturities, so current accounts, cash accounts, and so on. And on the right hand side here, you'd find derivatives, which are, as we've said before, combinations of basic patterns into more complex patterns, and also credit risk products like guarantees and repurchase agreements and stuff. To give you some idea about, what's that good for, right? So these are 3 select use cases that we have worked on in the past, and starting with BIAN, the Banking Industry Architecture Network, they actually have described in a rigorous way the different services, banking services that banks offer. And within those banking services, obviously, many of those services are somehow related to financial contracts. And what is interesting here is now to combine that banking services landscape of BIAN with an executable contract language or standard, which then allows to automate many of those processes in that landscape. Refinitiv, a financial information provider whom we have partnered with to look at how such a standard would allow them to create consistent analytics across different asset classes. And finally, and that's why we're here, that specification, that standard that Actus provides can also be used as a blueprint for creating smart contracts that are eventually deployed and executed on blockchain. And up here, you find the Marlowe logo. So we obviously have worked with the Marlowe team, and Dmytro will show some of that work after my talk here. Or then there is also another initiative where the same standards have been used as a blueprint for implementing smart contracts on Ethereum. So those are just some use cases that should show you where actually that model can be applied to. Now, what's Actus? We are actually a not-for-profit, incorporated in the US. We have 2 foundations, really. One targets the further development of the standards, the Financial Research Foundation, and the Users Association, where we involve industry, users, and users in general to collaborate in work groups and to improve those standards and find additional room for new products that we have missed and so on. So if you're interested in what we do, please reach out. We obviously always are looking for participation in that initiative. You can join working groups, you can participate in our user forums, which are happening every now and then. Can also support us financially. We are not for profit. We rely on participation on different levels. So please just reach out. Or also if you just want to have more information. You would find lots of materials online, particularly also on our GitHub. You find all those materials like the dictionary, like the specification, and there is a nice little demo app that you can find online too. So that's the first part of this session. I now want to hand over to Dmytro, and he'll show us live now what you can actually do with that on Marlowe now. We're excited about that. So Dmytro, please take over.
Hi everyone, I'm Dmytro. I'm a software engineer in IOHK. And I'm going to show you how we actually apply Actus in Marlowe. You already know that Actus stands for Algorithmic Contract Types Unified Standards. You've seen Actus taxonomy, but in this session, we were going mostly to be concerned about principal at maturity contract, basically either bond or some sort of loan. So how do Actus and Marlow combine together? Basically, for us, Actus gives us a way to infer those payments obligation given some contract terms and events and their history, and it standardizes contract terms. Meanwhile, Marlow provides verified and predictable financial DSL that allows to actually execute and render those liabilities on a blockchain in a smart contract. We also provide playground playground service that allows you to simulate and analyze particular contract. And we also provide the framework for formal verifications of Marlow contracts as well. So the goal of the Actus part of the Marlow project is to basically automate and evolve traditional finance with blockchain. And our first objective is to generate smart contracts from Actus contract terms, which we basically currently doing. And there are two challenges with this. Basically, first one is how to map risk factors that were mentioned earlier into blockchain. Because a risk factor is a parameter for a contract that is not known in advance. So it has to be dynamic, and we have to read it usually periodically from external data source like Oracle, which greatly affects the shape of a contract and its content. The second challenge we had was to support ad hoc events, basically those unscheduled events that could happen at any times. In this case, given that dates are not known in advance, we cannot be synchronous and just have a sort of blueprint of what and when is going to be executed. We got to use event-driven approach instead. Not every contract needs all those features. Not every contract needs risk factors, and not every contract needs unscheduled ad hoc events. So we designed several sort of variations, flavors of contracts. The simplest one is, we call it Actus F, just fixed contract, where we don't rely on external data sources. We don't, all risk factors are fixed to some default value. Like, for example, interest rate could be fixed to the one that is specified in the contract terms, and it's never reset into another value dynamically. And all schedules are pre-computed in advance as well, so every date of every event is known in advance. And in this case, we already know how much exactly who's going to pay who and how much and at which date. So it's the simplest contract that doesn't have any I/O except payments. A bit more complicated one is fixed schedules, is where there are no unscheduled events, only scheduled ones. But we interact with external data sources in order to read current state of the external environment in order to get risk factors. And the most complex one is Actus M, is the one that is event-driven, that I'll show you later, all of them. Again, as Nils mentioned, Actus is encoded in terms of scheduling, state initialization and transition, as well as payoff functions. In our particular case, we have a Haskell implementation of PAM contract, where semantics of Actus are described in generic polymorphic way that allows us to do code generation from Haskell. At the moment, we only generate Marlow, but technically we could generate even other languages and use the same Haskell code in order to generate implementations in different, let's say, smart contract engines. And the first example of how this contract would look like in Marlow. Let's say the simplest thing you can do with principal at maturity is to have a bond or sort of loan, just the simplest one, where at first, at initial date, you pay notional plus premium. And here are the corresponding formulas from Arctos specifications, which means here is notional, here is premium. And then at maturity date, another counterparty pays you back notional plus interest. Or simply this, you loan money and you get those money plus interest eventually. In Arctos F, the simplest version, you can represent this sort of contract by just literally saying when it's initial exchange date, party pays 1,000 ADA to counterparty. And when it's maturity date, counterparty pays 1,100 ADA to the party. And here you can see our blockly representations of the exact Marlow contract that can eventually be executed on a blockchain. So when some date, deposit 1,000, pay 1,000. When another date, deposit 1,100, pay 1,100. And here's how it looks on a playground. Basically, this is the actual Marlow syntax here. It's a language embedded in Haskell. And here you can simulate this stuff. If you actually go to the wirehack.marlow.iohk.dev.io, don't forget about HTTPS, then you'll see how it actually works. The second example is more dynamic, principal at maturity. In this case, it's same as static, but interest rate could be updated periodically on reset rate event. Still, every event like reset rate or interest payment is still scheduled with no dates in advance. It's just we need to get a new interest rate from time to time. Let's say your starting rate was 5%, then in 2 years it changed to 6 or 7, but the only way to know which value it changed to is to ask external data source that is not on chain, is actually off chain. So this requires an observation. However, when you have observation, it means that you cannot pre-compute the amounts of money, the payment obligations in advance anymore. So all the formulas have to be embedded into smart contract itself. Because let's say rate reset affects interest rate, which is variable, which is basically sort of contract variable. In its turn, it affects accrued interest and eventually the interest that you have to pay on interest payment event or maturity date. So while the process is kind of simple, it adds complexity to the contract. In this case, again, when some date happens, let's say in this case it's rate reset event, we have to observe a choice from an oracle, some value, like in this case, this variable would be like 5 or 6%, how much interest, what is interest rate right now, roughly saying. And here, every variable of Arctos, like accrued interest and eventually payoffs, are represented as formulas that are embedded in Marlow DSL. Here you see the simplified representation of Marlow DSL, and you can go to Playground to see how those formulas actually look. So it could get even more complex when you add asynchronous events. For example, prepayment event allows you to pay some part of the notional in advance. And in order to support it, we need more asynchronous approach. So we need to actually be able to update state independently of what kind of event happens. We don't know the date in advance, so we have to assume that there is no date, and not that there is no date if it's a synchronous event, and there is a date that we have to explicitly validate if it's a synchronous scheduled event, like initial exchange. So in this case, we have to be more explicit about modeling a state machine. If you've seen previously here, we have like T1, T2, and so on and so forth. States of the state variables are just the different points of time, just represented by convention, different names. So state machine is sort of unfolded. In this case, you have to fold it back and dispatch event type, and then apply formulas. So here it is. Here's the representation that allows you to do it. Basically, again, we just dispatch event type. Like in this case, if it's prepayment, then we calculate all new states and formulas for prepayment event. If it's rate reset, then we validate dates, validate current date against the one that is predicted by the schedule, and again we get a formula that gives us payment obligation eventually. Why we have to do it? Because in Marlow you cannot have a while loops. Marlow has a provable termination. So if you want to have some sort of recursive execution that could not terminate, you have to explicitly represent every step, explicitly sort of inline unfolded this recursion to a certain limited amount of steps that you know in advance. So for example, in this case, you can have like up to 20, let's say 30 unscheduled events allowed, no more than that. It's predefined before you submit the contract to the blockchain. Now, we are on the playground. If you want to play with at least Actus FFS versions, you can go to the Labs tab. Basically here, there is an experimental feature that allows you to input those contract terms, most of them, run a little bit, visualize their cash flows, and generate like static and reactive versions of the contract. Static versions if it's applicable. Yeah, if you visit again wirehack marlow.io hkdev.io, you can try this one out. Future work, what we're planning to add is basically derivatives, those composite contracts that depend on simpler ones. Swaps, basically it's a contract where you have already two, let's say, payment and maturities, but you want to exchange cash flows. This is basically swap. And parties just swap the money they receive. Futures is a contract that basically you exchange some, let's say, one asset for another at the date in the future, at some predefined date in the future, and predefined rate, obviously. And option is a contract where is like future, except that you instead of obligation to exchange, you have ability to exchange. You have a right to exchange. And if you don't, then you have to pay like then you lose your premium. And counterparty risk instruments that address counterparty risk are of high importance in case of blockchain. Basically, if you look at the contracts I just presented, you can notice that no one actually enforcing anyone to pay. Party can just walk away and don't pay. So what happens in that case? How to avoid this to happen? You lended money, you didn't get anything back. So credit enhancement allows you to do that. First approach would be guarantor, some other party that would guarantee you the payment. If someone doesn't pay, this party pays, and then it takes money from them. Other one is collateral. Is to put something as a collateral, something else. Like, for example, loans on a blockchain often allows you to put another cryptocurrency as a collateral, but you get lended money in something else. You can lend USDT and you use Bitcoin as a collateral. And also maybe for some purposes, we would consider using some sort of credit scores as tokens. Oh yeah, sorry, tokens as credit scores. As if you don't pay, then you lose some part of your credibility. The last thing we plan is ability is formal verification. Basically, in order to, there are several approaches we employ for testing actors. One obvious thing is to do sort of quick check tests against the reference implementation in Java that we're playing, but also some of the properties that we'd like to ensure cannot have to be ensured for all contracts. In this case, for example, for collisions, we need to be ensured that when we execute a contract on blockchain, order of events it would be irrelevant if they're scheduled on the same date. Internally, it means that events has to be sorted, but in order to ensure that it always works, we have to test it for all possible states of a contract. So this could be done with theorem provers, like in our case we use Isabel, and maybe we'll experiment with Agda. Another property we'd like to ensure is causality. It's ensure that all scheduled events, all past events that we expected to happen, scheduled ones, already happened when the present one is submitted. So ensure that people don't skip payments on a blockchain, because it would definitely break the whole logic. And the third one is hedging. It's more related to traditional finance, to quantitative finance, where we would like to at least check that every contract has a dual that would cancel the risks that introduced by some risk factors. In this case, it's just a nice test to one I do for the actors' formulas themselves to ensure that our implementation makes sense. And basically that's it. Please ask on the Marlowe side, you can contact me and Simon Thompson if you have some questions. And again, you can visit Biohack, marlowe.ihk.io, and even our previous version, alpha marlowe.ihk dev.io, if you want to see something less stable. Thank you very much. That's it.
So, Dmytro, now, or everyone actually, that would be now the Q&A section, right? where we do have another 20 minutes for taking questions. Now, Dmytro, how does it look at your end? I wasn't able to really enter the VR room, so I can't.
My
really
problem is that I was able to enter it, but it's so sluggy on my computer. I cannot even move inside.
Right. So similar, situation on my end. So that essentially means that we cannot really take your questions, which I guess isn't very satisfying. But so please reach out to us if you have questions after the session. And I guess we do have 20 minutes left almost, so we might want to do some more interactive session between you and me, Dmytro. So for the benefit of everyone who's here. So, I have some questions for you. You might have some stuff that you want to discuss, and hopefully that's a good a good way to bring more information across. So, let me start. I do, so we kind of, writing that specification for different use cases in a, let's say, technology agnostic way, so that different teams can actually look at that stuff and implement it themselves. So my question would just be, as a general feedback of how do you think, how do you think that standard helps you creating these awesome enforceable contracts for Cardano now? What's the aspect that you find helped you really there?
Basically, there are two nice things about Actus. One thing less practical, but it covers a lot of instruments in finance and it generalizes them. So it's easy to at least see what can we expect from the market. Meanwhile, it's helpful, but we're also looking into what exactly we could do for blockchain-specific things. Yeah, because on a blockchain, it's a little bit, not every contract maps exactly 100% on a blockchain. So we expect that maybe it would be easier to do with Actus, or at least research instruments you use an Actus specification and then specialize it into something more blockchain specific. Like, for example, stuff with collateral, we might not adopt the banking approach to credit enhancement, but we still definitely need credit enhancements on blockchain. So we might implement that part differently, but still be within Actus stuff. And that's where Actus helps, because we can already model some instruments, we can visualize them, we can see how it would behave in a real environment, and we can generate, with Actus specification, we can generate basically contracts from contract terms. And aside from this aspect, the more practical aspect is that many users, they are not familiar with programming, and even Blockly sometimes doesn't help if you're an analyst. And if you want to try out what can Marlowe do for you, you can go through simulation, but you sort of cannot write code. So when we just tell them hey, you can input contract terms in Actus, then they can input terms and get actual Marlowe contract and see how it actually works.
Yeah, right. Yeah, and I guess that's one, result also from the fact that, when we say it should be really technology agnostic, some of these very, technology specific aspects, like you've described, for instance, on blockchain, right, are also neglected, which then obviously, makes some aspects probably more difficult to use in some specific technologies. I guess that's just a result from that. We want to be very agnostic, but at the same time, if you are so agnostic, certain things may become harder in certain technologies, or you actually just have to introduce those things yourself or in a different way. And I can totally, I see that also with other teams, as I've mentioned before, who have implemented those on Ethereum. And I also, I guess it's a similar feedback that it's almost like a blueprint for you to implement certain contracts, but for some stuff that's specific to the technology, you do have to rethink certain aspects.
Yes. But at least we can rely on sort of accumulated knowledge and traditional finance, all those fees and interests and lots of parameters.
No, and also, I mean, so let's say creating smart contracts that are executable on a blockchain is one important aspect of the let's say life cycle of a financial product. You can automate a lot of the life cycle with such applications that you write, which is cool. And at the same time, there are other aspects that are very important, in particular, let's say in an institutional setting, which are around compliance, which are the clients that I can actually offer such a product, are around risk management for the risk manager to actually keep control over the risks he's at, and require actually also a let's say an off-chain treatment of those contracts in terms of he needs to be able to compute risk analytics, to compute pricing analytics, and so on. And I think that's another interesting aspect here. You can seamlessly just extract those terms and the state of a contract and plug that into a, let's say again, off-chain analytics engine that computes those things for you. I think that's an interesting aspect too.
Yeah, it's actually sometimes we basically that visualization I shown you of the cash flows is the simplest way to do it. Maybe in the future we even add something like Monte Carlo simulations, or at least primitive ones, and stuff that could at least demonstrate those features. Just for IOHK, this analytical part is more about maybe even educating new traders who come to blockchain and not that familiar with finance, but how the potential product that they might decide to use, how would it potentially behave, how it would look like before they actually try it. Yeah, it's like in Marlowe we have static analysis to ensure that the Marlowe code behaves as you expect, while Actus also lifts this into the space where you could say that your money gonna behave the way you expect, basically predict your payoffs eventually and plan your portfolio accordingly. So those two things, I guess that they we hope that in the future they attract like more professional and like reasonable traders to blockchain instruments.
Another area that I find very interesting and also probably worthwhile, I'm not sure if I've seen that on your future work list, but that would be interesting, I guess, is so let's assume we have this bond instrument, which is some form of a credit, a debt agreement, right? But then usually on a market you'd actually have not one investor, but you would have 100 or 1,000 investors, or I don't know how many, right? And we've heard before this morning from Jan Müller of IOHK2 about creating, I'm not sure what he called it, tokens or creating currencies or whatever on Cardano with Bluetooth, right? Yeah. And that's actually if we look at DeFi, for instance, or then also comparing that to the financial sector, the tokenization or just making, to fractionalize financial products, that would be another very interesting area. And I was just curious to hear whether there are any thoughts in your team about that you make possible for not just one investor to fund the contract, but to actually make, allow for many investors to fund the contract and then also to trade their shares in that contract with others.
Yeah, there are several aspects of it. We didn't think in that direction about Actus, because most of the coins that we implement, they sort of bipolar. Yeah, you can model many parties, but the simplest ones are have two parties, they're bilateral. But in general, what we do in Marlon, in that case, first one, we actually tokenize the roles. So basically, you can buy, transfer role in any contract. It's a more Marlo specific, but basically our Actus implementation at the moment, party and counterparty is actually our tokens that you can transfer. So basically, if you offer a contract, you can do that already for two parties. When we support composite contracts, we can compose it into something more complex. Or alternatively, we also looking at stuff like funds and like pooled stuff. For example, there were some things that people looked into, I think, stuff like automated market making agents, but basically the liquidity providers for exchanges. One of the things we discussed that could be potentially interesting. However, the problem with managing like complex funds and contracts is that they're a bit less standard and they require some manual intervention in the middle of the life cycle. So the more complex contract becomes, the more parties are in it, especially for contracts where like the whole exchange could participate in it. Every trader basically does it, and every trade is like monitored. They would require more abilities to manually intervene into a contract. That's one of the concerns we have. Even about simple Actus contracts, like banks would probably wanna change some of the semantics and have like logic more flexible. That's one of the reasons why we have like Haskell implementation that you can actually use as Haskell code, not just Marlow code. So basically, you can extend it if you like. You can adapt it to Plutus and execute it in Plutus potentially, maybe, and adapt it to Marlow, adapt it to other blockchains, and extend it. What's important for institution, I think, are 2 points: that they could extend and change logic, because again, their reporting flows might be different, and they would want to maybe store some information on chain to ensure something. And also, what's important is manual intervention. Like, can, let's say, two parties, or if it's a pool of parties, can they cancel contract in the middle and sort of do sort of reconciliation and start another contract that would continue the previous one? So we're thinking about multi-party problems and life cycles of the contract as well. Maybe Wire guys could help us with that. I don't know.
Yeah, no, I mean, I see, that some of these aspects are nothing that you would, just have covered with Actus, and I mean, that's perfectly fine. So it's interesting, to hear, that you saying that the parties in the contract are actually just tokens in some sense, which means the contract is tokenized already, and then you can transfer that role or that token to someone else, and then it would just be a generalization then that you can say you can actually create multiple tokens that you can trade in independently, representing one side of a contract. Huh?
Yeah. Even at the moment, it probably gonna change, but even Oracle is a sort of token, a party in a contract. Yeah. It's not more than that. That would change because we're extending. We're trying to get better support for oracles and Plutus. It's actually one of the future works in Marlow that is very important for Arctos. If we don't have oracles, we cannot.
Yeah, I agree. Yeah. Yeah, and that's now maybe off topic, but oracles. How does that landscape look on Cardano?
On Marlow side, we're planning to support. We're planning to support oracles from centralized providers for now that are actually signed values for Ethereum. So we're not sure how what is timelines on this, but it's at least one of the ideas we have. Yeah. And on IOHK's scale, we got Plutus. They actually actively discuss in oracles at the moment, especially what to do with oracles that could provide a lot of data to a lot of contracts, for example. Yeah. Who should pay, problems like who should pay for a transaction when it gets signed from Oracle, I should pay, or Oracle could pay, or how can we just split the pay between all the users that get values? Because in some cases Oracle could actually provide lots of values. In Arctos, it's usually like you get periodic, let's say, rate reset. It doesn't happen like every second, every minute.
Yeah, right.
Yeah, and it's not that much of data, so it's probably not expensive. But some contracts might require more massive amount of data, might be more reactive, which means it's a lot of transactions on the blockchain. So we're trying to optimize costs for interacting with Oracle. Also, they obviously looking into, I think they're looking into decentralized Oracle solutions as well.
I mean, there are different models, and you have to start somewhere, right? And then slowly find a solution that fits also the application. I guess there are different applications that require different solutions in terms of the degree of decentralization and so on.
Plus our blockchain model is different from, let's say, Ethereum. We have like a Bitcoin-like model, EUTXO, which means we have to, even if we take ideas that already work, we have to readapt them into like more stable environment that EUTXO probably provides for us.
So no, I mean, exciting stuff probably coming up, right? From within your team, but then also IOHK at large. Very excited about all those things, and obviously very excited to collaborating further here and create awesome Actors contracts within Marlow.
Yeah, likewise. We're also happy with Actors, at least for now.
Yeah, I think I just looking at the time, we're running out here. It was fun. Was fun chatting with you in that session here. I'm sorry, everyone on the call or in this session here for not being able to take your questions. Please reach out if you have anything.
It's pity that I like VR, but I cannot do VR in my work.
Okay.
It's much better.
Okay,
Thank you.
Bye-bye.